sharing my screen. And in sharing my screen, today we're going to look more at factoring, and we're going to look at factoring trinomials. Homework 26. I guess I should have written that down and I didn't. Homework 26 is due today. That's on the greatest common factor and factoring by grouping. I took a quick peruse of it in the grade book before we started today, and it looked like most of the folks who tried it were doing pretty swell. Though there were an awful lot of people who hadn't tried it yet. I have to apologize. I don't remember exactly whom had started it. Initially, I was planning on just taking a quick go over that homework before we started today. But I'll leave it up to you. Do you folks want to go over those problems before we get started with the next type of factoring today? Does anybody want to look at those?
Can we do a few, or depending on what anyone else wants to do?
Sure.
Look which ones ever you think are the hardest
Well,
or most difficult.
I am this math geek who kind of just enjoys factoring in my mind. Like I said before, it's like Math Jeopardy. You have to look backwards to see what the question was. Let's go through several of them, but let's go through them backwards, going on the assumption that the last ones are the more challenging ones. And the first one, some of those first questions, I think you'll notice are much more almost definition-y questions than, do the problem questions. So the last one in this assignment, number 23, gives you 2x squared minus 8xy minus 3x plus 12y. Let me ask you to factor by grouping. Does everybody remember from last class that we had said factoring by grouping is something that we usually do if we have 4 terms? So I look at this polynomial and I see there are 4 terms. First thing I always ask is there anything common to all 4 terms? And I see some of them are divisible by 2, but not all of them. Some of them are divisible by x, but not all of them. Some of them are divisible by y, but not all of them, and the same with 3. So I don't think there's anything that's common to all 4 terms. Everybody all right with that decision? Then we said if there's nothing common to all 4 of them, 4 is too many, so we want to split it in half and look at it 2 at a time. And so when I just look at these first 2 terms, is everybody all right? Both 2 and 8 are divisible by 2. So common factor would include 2. And both of them have a factor of x. So in the first 2, I have a common factor of 2x. And to find that other factor, we said we would divide them both by 2x, which gives me x minus 4y. And when I factor, I always do a quick mental check by multiplying back. 2x times x would give me 2x squared. 2x times minus 4y would give me minus 8xy. So is everybody comfortable with what we did on the front of this polynomial?
Yep.
Yes.
Now we want to do the same type of work with the back, because the first term is negative for my greatest common factor. And I know that 3 goes into 12. I'll take out negative 3. They both have a factor, 3 can go in them. They both have a variable, but they're different. So my only common factor is going to be that negative 3. And then to find the other factor, I'm going to divide by negative 3. And I'm going to get x minus 4y. Again, checking by multiplication. Negative 3 times x gives me my negative 3x. Negative 3 times negative 4y. Negative times negative is going to give me positive 12y. To this point, is everybody okay?
Yep.
If so, now I'm going to look at the big picture. And when I look at the big pictures, when I look at the two halves together, does everybody see they have a common factor of x minus 4y? And so if I think of dividing that common factor out of both, it's almost like just taking that x minus 4 y away from both of them. And the factor that remains would be 2x minus 3, looking at those coefficients in front. And so my final answer would be this product. So when we factor by grouping, what we do is we take a 4-term polynomial, and instead of looking at all 4 things at once, we look at the first 2, and then we look at the last 2, and then we keep our fingers and toes crossed, and if we did something right, each will have a common binomial factor. Should we try another one of these?
Yep.
So changing my pen back into a mouse and then back into a pen again. This time we have 5x plus 10 plus xy plus 2y. There's nothing common to all 4. So what should we do? Split it in half. And so now I'm just going to pay attention to this front half. 5x and 10. What would go into both 5x and 10?
5.
And so when I divide the 5 out of both of them, factored form, that would be my common factor, 5 times, after dividing, I get x plus 2. So far, so good.
Yes.
Then when I look at the back I have x, y, and 2y. Does everybody see that they both have a common factor of y? They're both positive. So I'll take out a positive y. And to find the other factor, I'm going to divide by y. And won't that leave me also with x plus 2? Do they share something, the left-hand side and the right-hand side? And they think they both have that x plus 2 in common. And so when I divide out the x plus 2, what would be left is 5 plus 1. All right? I don't think there were a lot of factoring by grouping in the homework. This next one, while it's got 4 terms, do you notice reading the directions? It doesn't say grouping, it just asks you to find the greatest common factor. So what we have here is 27x to the 8th plus 81x to the 4th minus 45x to the 6th plus 63. Now I know some folks, in order to find the common factor of the numbers, like to do their factor tree. But I'm wondering, does anybody recognize 27, 81, 45, and 63, pardon me, as all being factors divisible by the same number? Does anybody know offhand a number, the largest number that would go into all 4 of those evenly?
9.
So my greatest common factor numerically is 9. Now, in terms of the variables, you see how this last one doesn't have an x? So that's not going to be a common. So here, my only common factor is 9. And now to find that other factor that should have 4 terms, I'm going to think of dividing each one of these by 9. And that leaves me with 3x to the 8th plus 9x to the 4th minus 5x to the 6th plus 7. And that's the only thing that's common to all 4 terms. And so that'll be my final answer. All right. That one, okay.
Yeah, is that how you write it with the 9 in front of that? I guess I might have spaced that.
To write it in factored form, what we want to do is we want to show the factors, the things that multiply to give me
Oh, okay.
answer.
Okay.
And whatever, however you write it, it has to be equal to the answer.
Okay.
And if we do a check, we could do a check here by multiplying it back out. 9 times 3 is 27x to the 8th plus 9 times 9 is 81x to the 4th minus 9 times 5 is 45x to the 6th plus 9 times 7 is 63. And so when we're factoring, when we do our check, it should always take us back to the question that we started with. And our answer has to be everything that we would need in order for that to multiply to that.
Okay. And the GCF, without me factoring out all the numbers, would have been 2 groups of 3 to make the 9, right?
Right.
Okay, thank you.
Next one asks for the greatest common factor. And I'm guessing that this one is a little bit, hopefully a little bit less challenging for everybody. Red is such a threatening color. Let me change it. I've got 4x plus 16. Try looking. Can anybody think of the largest number that would divide both 4 and 16 evenly?
4.
4. Beautiful. If one of the numbers goes into the other, that's going to be a common factor. So in factored form, we have to show that this is equal to 4 times something. Now I know in the videos in my labs and other people say, okay, so now we have to think backwards and say, what would I distribute to get that? I think it's easier to find that if we just go through and divide both by 4. And that would leave me with 1x plus 4. And then again, I can check by distributing. 4 times x is 4x. 4 times 4 is 16. And so it checks. But my answer again is that factored form. Those things that showing the multiplication between them by writing them next to each other, those quantities that would multiply to give me my original problem. All right? Should we look at some more, or we have we got it? Next one is the one before it is along the same lines, except we're not writing a polynomial in factored form. We're just looking at those terms and saying, what is the largest common factor? So I've got 28x to the 7th. I've got negative 14x to the 8th. And I've got 7x to the 9th. First, I'm going to look at the numbers. 28, 14, and 7. Can anybody think of something that goes into the largest number, that goes into 28, 14, and 7 evenly?
7.
7. And because only one of them is negative, I'm going to say my common factor is that positive 7. Now, they all have variables. They all have an x. And you remember for the common factor, we're going to use the lowest exponent on that variable. So the lowest exponent on x is 7. So my greatest common factor will be 7x to the 7th. And I think those problems kind of cover all of the ideas that we looked at last class. Are you
And you
folks-
include the exponent because it's asking you the GCF for the list.
right?
Okay.
Should we do one more or are we good?
I'm good.
Good? All right, then today we're going to go a little bit beyond that common factoring and grouping to look at the idea of factoring trinomials. And again, when I factor a trinomial, I'm always going to first check for a common factor. And if there is a common factor, we'll take it out. But then after that, what I'm doing is I'm looking for two binomials that multiply to that trinomial. And so before we go through and look at factoring, I just want everybody to remember how you multiply trinomials. And so I'd like to look at a few examples of the product of binomials. And so for the first example, let's look at x plus 3 times x plus 8. And I know we have several ways of multiplying these. I think I've told you before, my favorite way is FOIL. I know some of you like to distribute and some of you like to box. Is everybody all right if we do this by that FOIL process, or do you guys want to distribute or box?
Could you just do
Foil's
distribute
good.
just as an example? Oh, like foil.
It's up to you guys.
Okay, we'll do this one all 3 ways, all right? Distributing, I'm going to take that x plus 3 and multiply it by the x. Then I'm going to take that x plus 3 and multiply it by the 8. So we're taking that x plus 3 and distributing it to the x and to the 8. That gives me, now I have to distribute again, x squared plus 3x. Over here distributing again, I'm going to get 8x plus 24. And so my answer is x squared plus 11x plus 24. Instead, if I were to do the FOIL, F means I'm multiplying the first in each. X times X is X squared. O means I'm multiplying the ones on the outside, the edges, which would give me 8X. I, the ones on the inside, would be the middle two, 3X. And L, the last, is the last from each parentheses, which gives me the 24. And I also get that X squared plus 11X plus 24. And so no matter how I multiply it, X plus 3 times X plus 8 is equal to X squared plus 11X plus 24. I'm going to be quiet for a minute and ask you folks to do the multiplication. And this time I want to look at X plus 3 times X minus 8. And I'm going to be quiet and ask you folks to multiply that out and tell me what you get. Let me know when you're close to done. What are you folks getting? Did I do okay? Did anybody else get X squared minus 5X minus 24?
Yes.
Now, you're going to get sick of these numbers. This time I want you to take X minus 3 times X plus 8. And tell me what you get.
Is
Anybody?
it
Go ahead.
X squared minus 3X?
That it would be how we start it. It would be X squared minus 3X. That would be distributing the X. Then we have to distribute the 8, right? And so that would give me plus 8X minus 24. So my final answer would be 8X plus 5X minus 24. That all right?
Yep.
And then last one, I want you to try X minus 3 times X minus 8. Is anybody else getting x squared minus 11x plus 24? So what I want to do right now is I want to compare each of these products to their factors, what I multiplied to get there. And if I have x squared plus, in general, we'll call it x squared plus bx plus c. Today, we're only going to look at where we have a coefficient of 1. And I want to show it as the product of two binomials. Each of the products start with 1x squared. Where did that x squared come from? How did we get x squared? Could we look at it as each time taking the product of the first terms of each, so that they'd start with x times x? And this is always going to be the product of the first terms of each binomial. So far, so good? Now I want to look at that last term, the constant term. Each of these had a constant term of 24. Where did each of those 24s come from? Weren't the 24s the product of the 3 and 8? And so whatever goes into these two spots has to multiply to my constant term. But now I want to look at something else with those products. I want to look at the signs. Do you see how this one is a positive 24 and this one is a positive 24? And do you see that when they're positive, it came from having, I apologize, I want to go down here, the same signs. So if this is positive, the signs are the same. And you notice if they're both negative, I had a negative in the middle. And if they're both positive, I had a positive in the middle. So if the positives, the signs are the same, and they're the same as the sign, on that middle term. See? Instead, if C is negative, well, that would be like when my 24 was negative. And do you notice when the 24 was negative, the signs were different? in the binomial. And then lastly, I want to look at that middle term. Guess I'll do that in yellow. If I look at those middle terms, if I look at B, this was -11. This was +5. This was -5. This was +11. Does everybody see that those middle terms are the sum of the two constants? 3 and 8 add to 11. +3 and -8 add to -5. -3 and +8 add to +5. And -3 and -8 add to -11. And so B is the sum of the constants. And so those two numbers multiply to C, but those two numbers add to B. And I've scribbled all over our products. But does everybody see those patterns? If so, we're going to take those patterns and what we know about the factors of numbers to try to factor some trinomials. Can I turn the page?
Can I ask a super quick question?
Sure.
This is just on the, when you distribute the x plus 3 times the x plus 8.
Mhm.
It's x times the parens x plus 3, and then 8 times x plus 3.
Mhm.
How do I determine which number I put on the outside to distribute?
Oh, you know what? When we had x plus 3 times x plus 8,
Yeah. Sorry to go backwards.
we're going to do this two ways, and you're going to see that they both give us the same results.
Okay.
I can think of taking the x plus 3 and distributing it over the other binomial. And so that would give me first the x plus 3 times the x, plus then it would be the x plus 3 times the 8. Does that make sense?
Yeah.
Or if you want to be one of those people, because multiplication is commutative, you would get the same answer if you took the x plus 8 and distributed over the first one. And if I distribute it that way, I would get x times x plus 8 plus 3 times x plus 8. They both will take you to exactly the same place.
Okay. That's where sometimes FOIL is just less messy.
Yes, I like, my favorite way again is the FOIL, x plus 3 times x plus 8. F is the first one of each. So x times x is x squared. O are the outer edges, the ones that are on the ends. So that would be my 8x x. I would be the inner two, the ones on the inside. Middle two, that's my 3x. And L would be the last one from each binomial, which is my 24. And they'll all of them will take you to the x squared plus 11x plus 24. And it's just a matter of which is your preference in terms of whether you distribute twice or you FOIL. All right?
Yeah, thank you.
Okay. So let's factor each of the following trinomials. And so let's start with x squared plus 7x plus 10. When I do these, when I factor, the first time I look at it is I ignore the middle term. I ask myself, what multiplies to x squared? And I think that could only be x times x. Is everybody all right there? Then I ask myself, what are the possible factors of the last term, 10? And I want to list everything that would work. So it could be 1 times 10, or it could be 2 times 5. Everybody with me so far? Then I look at the signs. Because the 10 is positive, it means my signs are going to be both the same. And if they're going to be both the same, the middle term tells me that they're both positive. I guess there should only be one S at the end of plus. Is everybody all right with just looking at that trinomial and seeing those? So when I have my x squared plus 7x plus 10, so far, because the x squared is x times x, I know that they're each going to start with an x. Because the last one's positive and the middle one's plus, I know that these are both plus signs. Now I'm going to look at my choices between 1 and 10 and 2 and 5. Which of these could give me a 7 in the middle? Which of those number pairs could possibly give me a 7? 1 and 10 or 2 and 5?
1 and 10.
How would 1 and 10 give me a 7? 1 plus 10 is 11.
Oh, I thought you meant include a 7.
No, it would, if the first is just 1x squared, they're actually going to have to add to 7 or subtract to 7.
Okay.
And so are you all right? The 2 and the 5 give me 7.
Yep.
And so my first guess is x squared plus 7x plus 10 is equal to x plus 2 times x plus 5. With these, it's really important that you check. And to check, what you'd have to do is you'd have to multiply the binomials. So when I take x plus 2 times x plus 5, first, well, I already knew that the first were going to give me x squared, right? Outer would be 5x. Inner would be 2x. And I already knew that the last would give me 10 because that's why I chose them, yes? And so I'm always now looking at that middle term and seeing if the outer and the inner give me my 7x. And it does. So it checked. And so my factored form, my answer would be x plus 2 times x plus 5. Now, the glass is half empty, the glass is half full. There's another possible correct answer for that, and that could be x plus 5 times x plus 2. You see, that one's got exactly the same factors. It's just we've used that commutative property to change the order of the multiplication. How's that one?
Okay.
Let's try some more. This time, let's factor x squared minus 7x plus 12. Again, x squared right now is only x times x. And I'm looking for numbers that multiply to 12. That could be 1 times 12. That could be 2 times 6. That could be 3 times 4. With me so far? Now, the factors of x squared are going to be the first factor, the first term in each binomial. Because this is positive, it means that my binomials have the same sign. But because this middle one is negative, they're going to be both negative. So that's almost like saying these would both have to be negative, right? Negative, 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 negative. Now, which of these would add to my 7? One and 12, 2 and 6, or 3 and 4? Anybody?
3 and 4.
3 and 4. And so that's what we're thinking our factors are. But again, let's go through and check. First is x squared. I knew that first would work. Outer is minus 4x. Inner is minus 3x. Last is positive 12. But we chose those numbers to get the first and the last. So I always like to joke. If I'm going to be lazy, I know my first will work, I know my last will work. What really bothers me is the oi, the outer and the inner. And so over here, my oi, my outer and the inner, do they give me that negative 7x? And so we've got it. That one, all right.
Yep.
Let's look at another one. Let's look at x squared minus 7x minus 30. And again, when I first factor a trinomial, I don't pay attention to the middle term. I pay attention to the first term to get x. My only choices are x times x. And now let's see, what would multiply to give us 30? 1 times 30, 2 times 15, 3 times 10, 5 times 6. What makes this one different is that 30 is negative, and since it's negative, it tells me that my signs are going to be different. So now I'm going to have x and x. I know that one's a positive and one's a negative. So since one's a positive and one's a negative, I could have negative 1 times positive 30, negative 2 times positive 15, negative 3 times positive 10, negative 5 times positive 6. Or couldn't I have positive 1 times negative 30, positive 2 times negative 15, positive 3 times negative 10, or positive 5 times negative 6. Like lots and lots of possibilities. Which of those possibilities could, because again, I only have 1x squared, which of those possibilities, now I'm looking at the middle, add to negative 7? Negative 1 and 30 would be positive 29. These guys add to positive 13. These guys add to positive 7. I don't want positive 7, I want negative 7. So I'm going to go look over here. Is everybody all right? 3 plus negative 10 would give me my negative 7. And so I'm going to try the plus 3 minus, it's not minus 7, I apologize, minus 10. When I multiply, first, we knew would give us x squared. Outer gives me negative 10x. Inner gives me positive 3x. Last gives me negative 30. When I look at those like terms in the middle, negative 10x plus 3x would give me negative 7x. And so it checks. But again, my answer is this factored form. How is it?
Okay.
Next one's going to be a little bit different. Next one, I'm going to have c to the third plus 8c squared minus 48c. What do you folks notice that's different about this one? Anybody see anything different?
More exponents.
There's more exponents, right? There's more like of a lot of things going on, right? Don't they all have a C? And so this one, before I begin, I'm going to look to see, is there a greatest common factor? Is there anything that goes into all three terms? And because they all have a C, I'm going to say yes. The greatest common factor is C. So I'm going to have a common factor of C. And then when I divide each of those by C, I'm left with C squared plus 8C minus 48. And now that I've factored the C out, I need to try to factor the trinomial. Sometimes they will be factorable, sometimes they won't. How do you spell trinomial? T-I-R-I-N-O-M-I-A-L. That's so embarrassing when I'm in a room full of intelligent people and I get halfway through a word and forget to spell it. I'm so sorry. And it happens to me probably more than most people. Spelling was never my forte. And in thinking about the math and in thinking about writing on the touch screen, all of a sudden the spelling skills are the first to go. So I've got C squared, pardon me, plus 8C minus 48. C squared is going to be C times C. Because that's negative. Is everybody all right? That's telling me that I'm going to have different signs. So one's going to be a plus and one's going to be a minus. And now to fill in these blanks, I'm going to look at the factors of 48. 48 could be 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. And again, one's going to be positive and one's going to be negative. If one's positive and one's negative, so I have those different signs, with the different signs, which would likely add to 8. -1 and positive 48 would be 47. -2 and positive 24 would be 22. -3 and 16, see, -3 plus 16 would give me 13. No, not there. How about if I have -4 plus 12? What do I get? Doesn't that add to 8?
Yep.
So we'll have plus 12 minus 4. For my final answer, this common factor of C can't get lost. So I'm going to put that C in front. And so when I do my check, boiling these two first gives me first C squared, outer minus 4C, inner plus 12C, last minus 48. So that gives me C times C squared plus 8C minus 48. And then if I distribute, I get C to the third plus 8C squared minus 48C. And if I go back to the top, that was my original question. So I nailed it. But what you have to remember, my answer is all 3 factors. That all right?
The first step that we do in the top when you divide it by C is just to reduce it more as much as you can,
You're always, if there's a
or
common,
simplify it.
if there's a common factor, take that common factor out first, because it's going to make your life a heck of a lot easier. Let's look at another one. Next one, I want to look at 3x squared plus 6xy minus 105y squared. And so again, my checklist for factoring, the first type of factoring we learned about was common factoring. So I'm wondering, is there anything common to all 3 terms? Some of them have x's, some of them have y's, but there's not a common variable. But let me look at the coefficients. Let me look at the numbers. Is there a number that goes into 3, 6, and 105 evenly? Three goes into 6. Does 3 go into 105?
Yes.
Yeah. So my greatest common factor is going to be 3. And so before I begin, I'm going to take out that factor of 3. And to find what trinomial I'm left with, I'm going to divide them all by 3 and get x squared plus 2xy minus 35y squared. Now my x squared, only choices are x times x. Don't want to lose that 3. X times x. Because this is negative, is everybody all right? That tells me I'm going to have different signs. One's going to be a plus and one's going to be a minus. Now, I'm going to look for things that don't just multiply to 35, but multiply to 35 y squared. And so 35, when we were making our list of multiples of that constant, first thing we did was we took 1 times 35. Because it's a y squared, I'm going to look at 1y and 35y. With different signs, will they ever add to 2? No. 1 and 35 with different signs, I think I'd be getting either positive or negative 34. What else multiplies to 35?
7 times 5.
Yep, 5y and 7y. And now with different signs, if one is positive and one is negative, will I ever get that positive 2 in the middle? Well, I think if I had negative 5 and a positive 7, negative plus positive, and the signs are different, we take a difference, use the sign of the greater, that's going to give me that positive 2 in the middle. So I'm going to put the 5y behind the minus and the 7y behind the plus. And now I'm going to do my check by FOILing. First is x squared. Outer, x times minus 5y. When I multiply those outer, x times minus 5y. Do you see it's going to give me that minus 5xy? And when I multiply the inner, that's going to give me positive 7xy. And then the last we made sure of was going to give me my negative 35y squared. And so do you see that FOILing process? If the first terms both have x's and the last terms both have y's, do you see it gives me that xy in the middle? And so I've got 3 times x squared plus 2xy minus 35y squared. And when I distribute the 3, I get 3x squared plus 6xy minus 105y squared, which is what I wanted. But all of this, all 3 factors would be my answer, my factored form. What do you think?
I think I like spelling better.
Oh,
It's
no.
okay. It's all right.
Let's look at x squared minus 7x plus 6. And I am going to totally shut up and let you folks work on this one for a minute. And tell me what you get. How are you folks doing? Did anybody else get x minus 1 times x minus 6? Right, I'm getting total silence. This is terrifying me.
I got it, but I just messed up remembering that the different signs mean they're both negative. So I had x plus 6 and x minus 1. I made the signs different
No,
instead of the same.
if they multiply to be a positive, if that last one is positive, the signs are always going to be the same. And if they're the same, they will always be with the middle sign.